we're going to look at word problems where we're really doing these confidence intervals in full and where we're going to have to pull out all the important information. So this first question tells us a charity wants to estimate how much money the average donor gives. A random sample of 97 donors, so that 97 is going to be my sample size N. Had a mean donation of $280. That's going to be my X bar, 280. Construct a 90% confidence interval, so my confidence is going to equal 0.90. Assume the standard deviation to be $88, so my sigma is going to be 88. I need to pull out these four key things. Once I have them, this problem works just like the ones that we did at the top of the page. So here what I'm going to need to do is say for 90% confidence, my margin of error should use 1.645. So when I'm calculating margin of error, I should be doing 1.645 times sigma, which was given to me as 88, over the root of n, which was given to me as 97. When I put that all into my calculator, 1.645 times 88 divided by the root of 97, I get a margin of error of 14.698, which I'm going to call 14.7. I then just need to take the given mean of 280 and do 280 minus that margin of error, 14.7, and then 280 plus that margin of error of 14.7. When I do the minus, 280 minus 14.7 gives me 265.3. When I do 280 plus 14.7, it gives me 294.7. So this is the final confidence interval for this word problem. Basically, I can say that I'm 90% sure that the true population mean donation is between $265.30 and $294.70. Question 8 asks me to do the same kind of math, just with much bigger numbers. So it says the voice wants to estimate how many people will vote this week, a random sample of the last 48 shows. If the sample has 48 shows in it, then my N equals 48. Had a mean of 3 million votes. That's my X bar, 3 million. Construct a 99% confidence interval, so C equals 0.99. And assume the standard deviation is 1 million votes, so sigma equals 1 million. Same idea. Once I'm able to label the four things I need, I start by calculating my margin of error. In this case, my margin of error equals, for a 99% confidence interval, I should be using the number 2.575 times my given sigma, 1 million, divided by the root of n, in this case 48. When I put that into my calculator, 2.575 times 1 million divided by the root of 48 gives me 371,669. I'm not going to include any decimals because really these are huge numbers, so this has gone to a bunch of places anyway. I now need to take my X bar 3 million, subtract that 371,669, and take the same 3 million and add 371,669. In general, these commas can get a little confusing, so when I write final answers, I leave just the one comma separating lower bound and upper bound, which makes big numbers like this a little confusing. If you left the commas in, I don't think it's a huge deal, but it is something where you want to make sure that this comma is, I guess, slightly bigger to show that that's what's separating the lower bound from the upper bound. When I do 3 million minus 371,669, that gives me a lower bound of 262,831. When I do it instead as adding, that gives me an upper bound of 3,371,669. So what this really says is that the voice is 99% sure that the true number of people that will vote this week is between 2,628,000 and 3,371,000.